Today we are going to discuss how a context-free grammar can be converted to a PDA. In the previous class, we have discussed PDA and CFG are equivalent and how a PDA can be converted to a CFG. And now it's very easy to convert a context-free grammar to its equivalent PDA. Here, the rules for doing this: first of all, we have to convert the given set of productions into GNF. If a context-free grammar is in GNF form is in one of the earlier classes we have discussed. That means every production is of the form A derives A alpha. That means the first symbol on the right hand side is A or a single non-terminal, single terminal. That means it is starting the single terminal. Okay, A derives alpha. The right hand side should start with a terminal. That is, if you have a set of productions, first of all you have to convert that to GNF. That means every production after conversion will be having terminal on the right hand side. Starting the terminal on the right hand side. Okay. Now PDA will only have a single state. See, that is the most important point. Here, when we are converting a PDA to its equivalent or CFG, you may have number of states. In the original PDA you may have a number of states, but when we are converting a context-free grammar to PDA, then that PDA is having only a single state and that is represented by Q. Okay. Now, the initial symbol of context-free grammar is represented by G is equal to variables, terminals, productions and start symbol. Here for this PDA also, the initial symbol is this one, S. Initial symbol will be that. And now we are going to have for non-terminals and the following rule: Q epsilon, delta of Q epsilon A equal to Q alpha, where A derives alpha. If you have such a production, A derives alpha, then you have to replace that A derives alpha. This is a context-free grammar and A derives alpha has to be replaced with this rule. Okay, alpha, that means A derives alpha, that means here as it is having only a single state, delta of Q epsilon A derives Q alpha, that means states are not changing. Left hand side and right hand side the same state Q, and epsilon A, here we have to put A here and alpha on the right hand side. If it is a for all non-terminals, you have to do this. For all non-terminals, you have to do this. And for each terminal symbol, add the following rule. For each non-terminal symbol, for each terminal symbol, you have to add the following rule. That means delta of QAA derives Q epsilon. So I will show you how to do that. Here, this is a grammar is given, and I am going to generate the PDA equivalent to this. S derives A and A derives AS, BS or A. Now convert the given set of productions to GNF. This is already in GNF. Why? Here the right hand side of this is starting with A, which is a terminal. Here A derives AS, again this is a terminal. A derives BS, again this is a terminal, and A derives A, that is also a terminal. And this is in Grabach normal form. PDA will only have a single state Q. That means PDA is having only a single state. That you should remember. The initial symbol of the CFG will be the initial symbol of PDA. That means initial symbol of this PDA, that is S. That is the same as the initial symbol of PDA. For non-terminals, add the following rule. Here, what are the non-terminals? Non-terminals. Here, in this case, non-terminals are S, A. And what are the terminals? Terminals A and B. A, B. Then, as per rule number 4, for non-terminals, add the following rule. That is for non-terminals S and A. Here we are having S and A. And now I am going to have this type of production. We have A derives alpha. So we have S derives S derives A. This is A derives alpha. This is just like A derives alpha. I'm going to replace that with delta of Q. That means Q epsilon. Here A stands for S. S derives what? Q comma alpha. Q comma A. This is the first rule. That means for non-terminal S, this is the rule, and for non-terminal A, I am going to have delta of Q epsilon. I'm going to write instead of S, I am going to write A here. A derives, which is a set, as it is a non-deterministic PDA. We have a set. A derives AS, BS or A. Can either replace that with AS or BS or A. That means you are going to have Q comma AS or Q comma BS or can have Q comma A. That's it. That means here delta of Q epsilon A is a set. Either you can use this one Q comma AS or Q comma BS or Q comma A. So for non-terminals add the following rule. So I have completed the non-terminals S and A. These are the S product S. These are the productions which we have derived from S derives A and these are the set of production. This is the moves which we have created from A derives from the production A derives AS or BS or A. And now for each terminal symbol add the following rule. Delta of QAA derives Q epsilon. So here that is the last portion. That means here how many terminal symbols are there? A and B. So delta of QAA equal to Q epsilon and delta of QBB derives Q epsilon. Okay, delta of QAA derives Q epsilon and delta of QBB derives. That means for each terminal symbol add the following rules. So these are the rules you have to, these are the moves we have developed. That means this is the PDA which we have developed from that context free grammar. And I will show you another example also. And after that, after doing that example, I will show you how whether this is true or not with an example. Now we are going to do another problem. That means convert to PDA. This S derives 0 BP and B derives 0S, 1S or 0, and check whether this is a valid string according to this grammar using that PDA. Okay, that we are going to discuss. Now this is already in Grabhook normal form, and now we are going to convert the non-terminals and terminals. Here non-terminals are S and B, S comma B, and terminals are 0 and 1. Okay. Now for each non-terminal add the following rule. For each non-terminal add the following rule. That means Q delta of Q epsilon S derives Q epsilon S. That means for each non-terminal A, if you have A derives alpha, that means this is 0 BB. Now we are going to replace that with Q comma 0 BB. Okay. And what are the B productions? That means for each non-terminal, for non-terminal S we have written this, and for non-terminal B, this is Q epsilon B derives. How many B productions are there? 0S, 1S or 0. Now you have a set which is q comma 0s, q comma 1s, or q comma 0, q comma 0. So this is another move, this is another move. This is move of, this is a move, and this also is another move. This is a non-deterministic, that means three possibilities are here. Now see, now this portion is over, and for terminals 0 and 1, for terminals 0 and 1, what we are going to do is delta of QA derives Q epsilon. So delta of Q0 0 derives Q epsilon, and delta of Q1 1 derives Q epsilon. Okay, so those are the rules, and now we are going to verify whether 0 1 0 0 0 0 is acceptable. For that, I am going to run this portion. Now see, delta of initially that will be in state Q, and delta of Q epsilon s, delta of Q epsilon s. Now this is the input string is 0 1 0 0 0 0 0 1 0 0 0 0, and this is the start symbol. And now see Q0s, Q0s, we don't have any Q0s, we have Q epsilon s. That means without reading any input symbol, can push this. Okay, 0 BB. That means the input point without moving the input, without reading this 0, Q epsilon s. That means without reading anything, you can push 0 BB onto the stack. That means this one derives what? This one derives. Now we are having Q 0 1 4 zeros, and after that you have 0 B B. These are the instantaneous descriptions. Instantaneous description. From this we have generated this, and from that we are going to have. That means the next step is starting from here, delta of, if Q 0 1 0, Q 0 1 0, that means Q epsilon. That means you are popping this 0 and you are advancing, and that means the next stage is Q, and as you have advanced, you have that means now after this only this much remains, and 0 0 0 comma this 0 you have popped, and B B. Okay, and Q1B. Q1B is not here. Q epsilon B is there. Q epsilon B, that means without reading any input symbol, that means Q epsilon B, what will happen? Q epsilon B, you have Q0s. Means here Q, this one remains the same, 1 0 0 0 0 comma. This B is replaced with, that means Q epsilon B is replaced with 1s, that means 1s, and 1B remains. Okay. Now what is this? Q11, that means Q next input symbol is 1 and 1 is on top of the stack. Q11, you are going to pop it. Now after popping that, Q, That means after popping this one 0 0 0 0 and BB is here, not BB. After popping this SB, SB. Okay, that one. Okay. Now, what about Q0S? It is not there. Q epsilon S is there. Q epsilon S. Q epsilon S is there. That is after popping S, we are pushing 0 BB. After popping S, we are pushing 0 BB. That means this is Q. The input remains the same 0 0 and you have popping S and pushing 0 BB. That means 0 BB. After that again you have a B. Okay. And now Q00. What is Q00? Again popping this 0 and we are advancing. What remains is this one. Okay. Now this is Q 3 zeros B B B. What will happen? Q0B. Q0B. We don't have any products like this. Q epsilon B is there. Now I am going to intentionally choose this Q0. Q0. That means actually when you're doing this, you have to take three cases and one of them will be accepted. But in this case, I am choosing this Q0. Okay. Now when this is Q epsilon and blank symbol, epsilon and B, Q0. That means after popping this B, you are pushing 0 and now that become Q 0 0 0 and this is 0 B B. Now this Q00, we are going to pop it. That is Q. After popping this, we are advancing. Now two zeros remains and now BB. Okay. After that, Q epsilon B. Q epsilon B is again Q0. I am going to replace this with 0, which is Q 0 0 0 B. And now this is Q00. We are going to pop this and advancing. Going to have Q0B and Q0. Q epsilon B is Q0, which is Q. This is 0 and this is 0. And Q00 means you are Q00. That means you are Q epsilon epsilon, and in that case that is accepted. And as per this, that means this is a valid string according to this grammar. Using PDA we have proved it. Okay, that means it's very easy to convert a context free grammar to its equivalent PDA, but PDA to CFG conversion is little bit difficult. So PDA and CFG are equivalent, and conversion from PDA to CFG as well as CFG to PDA has to be done, and the examination point of view also is very important. You have to study this very well. Thank you.